Welcome to this video. This is Sophia from EagleCooleer. In next few minutes, I will explain what airflow of DC fan is and how to get the right airflow for your cooling. When determining the required airflow for your system through thermal simulation or calculation, note that this airflow is referred to as the effective airflow, which is a completely different concept from the maximum airflow indicated in specifications you see. Maximum airflow and pressure are measured under ideal conditions, maximum airflow measured at zero air pressure and maximum air pressure at zero airflow. When we install the fan into air tunnel for testing, which will give us the fan's airflow static pressure characteristic curve, also known as the PQ curve, as shown in the left. By obtaining the fan's PQ curve and combining it with your system impedance curve, we can identify the operating point, OP, for your system. This is the point where the fan's PQ curve and the system's impedance curve intersect. For examples, as the figure shown in the left, maximum airflow and air pressure of fan A is higher than fan B. However, since the intersection of fan B PQ is higher than fan B is better solution. For high impedance systems, high pressure DC fan can be selected. Whereas, for low impedance systems, it is better to choose a high airflow fan. As shown in the figure, for S system, fan A with high air pressure will be better. For S system, fan B with high air volume will be more suitable. Usually, we can't measure system impedance very accurately. So, it's a good idea to pick a cooling fan that can handle 1.5 to 2 times more airflow than your need. When choosing a fan, just looking at the maximum airflow listed in the specs isn't enough. Airflow isn't the only factor in measuring cooling effectiveness. It's also important to choose the right cooling fan based on the system's impedance. Here is some more information about PQ curve analysis. According to the flow conditions of the airflow, the entire PQ curve can be divided into 3 areas: operating zone, stall zone, and reflow zone. We have to make the system operating point fall within the operating zone. You can see the airflow in the operating zone is only partially separated at the root of the impeller. Most areas maintain a laminar flow state and the flow is relatively uniform. In the stall zone, the airflow separation at the root of the impeller is already significant, and in the reflow zone, there is an obvious secondary return flow. If the system's operating point falls in the stall zone and reflow zone of the PQ curve, it will cause fan resonance and noise increase problem. Therefore, we have tried to make the system's operating point fall in the operating zone. Through our explanation, I hope you have a clear picture how to get the right airflow when you choose a DC fan. If any other questions, please email or call us.